Who do you call when you are in trouble? Super Burgess. The evil villain Dr. Burglet has been stealing pencils. So naturally, Super Burgess came to the rescue. In order to stop Dr. Burglet, Super Burgess assembled a group of students to defeat him in a water balloon fight.
The water balloons are thrown at a velocity of 135 feet per second. The water balloons were 5.5 feet off the ground and were thrown at an angle of 45 degrees. Super Burgess was able to use his super strength to throw the balloon.
To solve for when the balloon was at its highest, first you have to put in the y equation, which is negative 16 t squared plus 135 sine 45 degrees t plus 5.5. To solve for the line of symmetry, it is negative b over 2a. And so when you plug that in, you find t is equal to negative 135 sine 45 degrees, and then you divide that by negative 32, and then you find that t is equal to 3.6 seconds. When asked the question, how long was the balloon in the air, you need to find a way to graph it. So let's start out by making a graph. So it starts out right here at 5.5, roughly about there. And so it's going to go up here, and then it's going to go back down again. And you can see that there's another 0 right here, but it's negative, so we can't use that. But there is a 0 right here, and you find that the coordinate for this is 7.2270, which means that the balloon was in the air for 7.227 seconds. So to find out when the balloon hit Dr. Burglet, you are going to have to keep in mind the value that we found earlier for its maximum point, which was at 3.6 seconds. So what we are going to do is that we are going to take the y equation and plug in 3.6 seconds. So it's going to be y equals negative 16, 3.6 squared plus 135 sine 45 degrees times 3.6, and then you're going to add 5.5 to it. And then once you calculate all that, you get a y is equal to 211.7 feet.
The world-renowned trapeze artist Rory Gilmore is an acrobat in the Luke Dane Circus. Before leaving for Yale, she decided to have one last performance at STEM. For her trapeze act, she needs to flip over a vault that is 40 feet high. She flips over at a rate of 50 feet per second and at an angle of 20 degrees. So the first question asks, how long was she in the air? We can do this by simply sketching a graph of the equation that we have. So our equation was y equals negative 16t squared plus 50 sine of 20t plus 40. And we're going to graph that here. The y-intercept value was 40, so it's going to intercept at 40, 0, 40. And we can simply sketch a graph following the trajectory going to the maximum point all the way back to the x-axis. Notice how there's two zeros here, but we can't use this 0 here because this is a real-life scenario. There's not going to be a negative position, ever. So we're going to focus on just this part. At this point, at the x-axis, this tells us how long it was essentially in the air, since this was the time it was in the air. As you can see, this point is equal to 3.560, which means that she was in the air for approximately 3.56 seconds. So in the first part of the second question, we need to figure out when did she reach the highest point. And we can use this by using the equation that we stated earlier, which was y equals negative 16t squared plus 50 sine of 20t plus 40. To find the x value, we can simply use the equation negative b over 2a, which is the line of symmetry, which tells us where the maximum point is. So we just plug the values for b and 2a to give us negative 50 sine of 20 divided by negative 32, which gives us an x value of 1.43 seconds, meaning her highest point was when she was in the air for 1.43 seconds. The next question asks, how high did she go? So we're going to use the same value that we used earlier, which told us that she was in the air for 1.3 seconds. The highest point is usually on the maximum value, and since the x value that we found earlier is the point at which it goes the highest, we can plug that value into our equation to find the maximum y value. So using that, we're going to plug in negative 16 times 1.43 squared plus 50 sine of 20 times 1.43 plus 40, which results in a y value of 72.56 feet, meaning that she went at a height of 72.56 feet. So our last question asks, did she fly over the vault? So let's recall from our problem, it stated that the vault was 60 feet high. And we remember that our y value, her highest point, was that she got as high as 72.56 feet. So if we were to assume that she went over the vault, this means that because her highest point was at 72.56 feet, that yes, she did fly over the vault, because 72.56 feet is larger than 60 feet.